Hi, today we're going to start reviewing angle relationships for the upcoming test. The first 5 problems are just some true and false. When I look at number 1, it says a right angle can measure 89.5 degrees. And while 89.5 does round to 90 degrees, a right angle has to be exactly 90 degrees. So this angle is a little too small. I have to call it acute. So I have to say this is false. Number 2, an obtuse angle can measure 180 degrees. So an obtuse angle, or 180 degrees, is going to be one side of a line, which when we get to high school we learn is called a straight angle, not an obtuse angle. So no, I cannot call that an obtuse angle. I have to classify it as a straight angle. Okay. Number 3, an angle bisector divides an angle into 2 equal halves. The definition of bisector is to divide into 2 equal halves. So if it's an angle bisector, then yes, that's exactly what it does. It divides an angle into 2 equal halves. That is a true statement. Number 4, when given an angle bisector, you can set the 2 smaller angles equal to each other. Yes, because number 4. Angles that share a vertex are called adjacent angles. So adjacent angles are 2 angles that share a vertex and share a side. So they need to do more than just share a vertex. So while these are adjacent, and actually they're a linear pair, right? You could also have angles that share this vertex but are not adjacent. So for example, these, which we call a vertical pair, right? A vertical pair of angles, would not be adjacent. So just because they share a vertex, that's not enough to call them adjacent angles. They could be adjacent, but they don't have to be, so this is a false statement. Okay? Now number 5. When given an angle bisector, you can set the 2 smaller angles equal to each other. Yes, because just like on number 3, we did say an angle bisector divides an angle into 2 equal halves. So you can set the 2 halves equal to each other. That is a true statement. Okay? All right, so let's look at number 6, 7, and 8. On number 6, I can see a couple things. I have adjacent angles, x and 62 degrees. I know they're adjacent because they share this vertex and they share this side. They're also complementary. I know that because I can see they make a 90-degree angles when I put them together. So my 62 plus my x is going to equal 90 degrees. So when I solve that, I'm just going to take away 62 on both sides. And I'm going to get that my angle x equals 28 degrees. So that my 28 and my 62 together make my 90. Okay? All right, when I look at the next one, I have an x degree, I have a 100 degree, and then this one doesn't have an expression on it. However, since I see these matching arc marks, I know if this one is x, this angle is also x. The 3 angles here make up one whole side of this line, which means together they all make 180 degrees. So x plus 100 plus x should equal 180 degrees. First thing I'm going to do is I'm going to combine my like terms. X plus x is 2x plus 100 equals 180. I'm going to zoom that in. It's a little bit small over there. Let's see if we can get a little closer. There we go. All right, I'm going to subtract my 100 on both sides. Subtraction property of equality. And I'll get 2x equals 80. Division property of equality to remove the 2 or to reduce the 2. And I end up with x equals 40. So if I look here, this angle is 40 degrees. This angle is 40 degrees, and my 40 plus my 100 plus my 40 make one side of the line 180 degrees. Okay? Let's look at number 8. Number 8 is a lot like number 6, where I can see I have 2 adjacent angles. and together they make 90. But I'm not going to be able to do like I did over here and just simply subtract by 62. That's why I always go ahead and set it up algebraically to solve it, even though I could look at this and go, oh, I just have to subtract from 62. Because when we get to a problem like this one, it's not as easy to just say, oh, I just need to subtract by whatever, right? Instead, I need to realize that my two adjacent angles add up to make the complementary total of 90 degrees. So my 4x plus my x make 90 degrees. Okay? 4x plus x is 5x, and that equals 90 degrees. I'm going to use my division property of equality to eliminate the x in front of the 5 in front of the x, or to reduce it to 1. X equals 90 divided by 5 is 18. Just checking my math. Yep, 18. Okay, so I know this angle is 18 degrees. And then just to check my math to make sure it's correct, I'm going to go ahead and do my 4 times x, 4 times 18, and I get 72 degrees. And then I can check my 72 plus my 18. Does that make the total of 90? Yes, it does. Okay, so I can feel confident in my answer. All right, let's look at this next little problem down here. Use the given information to find x, then find each angle. Notice they didn't give me a picture. So the first thing I want to do on this problem is I'm going to draw myself a picture. Okay? I have ray BE bisects angle ABF, and I don't know how big angle ABF is, but because sometimes I write kind of big, I'm going to make it a nice obtuse angle to give myself plenty of room to work with. This is angle ABF, so B is in the middle, and then A and F can go on either side. Ray BE is bisecting it, so it's dividing it in half. So it's coming out like this, and it's dividing it into 2 equal pieces, and it's ray B that goes through E. So now that I have my picture drawn, I can go ahead and start filling it in. Angle ABE equals 2x plus 7. So A, B, E equals 2x plus 7. Okay. Angle EBF equals 4x minus 13. EBF equals 4x minus 13. Okay. Now, before we had taken these two angles, the first thing we did when we were given two expressions is we added them together and put what they equal. My problem is here, they haven't told me anywhere what this whole angle is equal to. So I can't add and then say equal, okay? But I do see the word bisect. And remember, that's what allowed us to put these matching arc marks, because we know that means the two angles become equal. Only because I see the word bisect. If I didn't see the word bisect, I would have to add these two angles together. Okay? All right, so now this is totally solvable, right? I'm going to move my smaller x because I like to keep my x's positive. So I'm going to subtract 2x on both sides. And it's going to leave me with 7 equals 4x, or 4x minus 2x, which is 2x, and then minus 13. I'm going to add 13 on both sides, which is going to leave me with 20 equals 2x plus 0, which is just 2x. Division property of equality, divide both sides by 2. And 10 equals x. Okay? It still wants me to find the measure of angle ABE. ABE is my orange angle. So I'm going to put a 10 in for 2. So 2 times 10 plus 7. 2 times 10 is 20 plus 7. This angle is 27 degrees. Which means this one should also be 27 degrees, and I could just write that down if I'm confident in my math. But if I'm not, if I got x wrong, and I just go 27, 27, then I'm going to have all 3 of them wrong, and I won't have checked my work. Whereas, if I come over here and I do 4 times x minus 13, and I plug in my 10, and I do 4 times 10 is 40, and 40 minus 13 is 27. So we can feel confident that we did do our math correctly. Okay? There's still one more angle there it wants me to find. It wants me to find the measure of angle ABF. So where is angle ABF? A, B, F. Oh, that's the whole thing, right? So that's going to be 27 plus 27 will give me the whole angle. So that's going to be 54 degrees. Okay? All right, we'll go ahead and pause there on this video, and we'll pick up with the review in the next one. Thank you so much for watching.